Today we're going to be talking about advanced approaches to traffic inspection and network diagnosis with AWS. I'm your presenter, Ashraf. I also have my colleague, Jeff, who unfortunately still not here. So I'm going to be taking his part, the first part of the presentation. So please cope with me for some of the information regarding the slides. Great. So today today's agenda, we're gonna talk about a few things. We're gonna talk about why we inspect traffic, what are the challenges that customers go through, different scenarios with that, the services that we provide from AWS about logging, monitoring your traffic in the AWS. We're gonna talk about specifically some of the services that we have, like WAFF, VPC traffic monitoring from diagnose and logging perspective. And then we're gonna go deeper into different network topologies and how we inspect traffic at the different layers. We're gonna talk about more services like Network Firewall that we have, gateway load balancers, and how we can inspect traffic east, west, north, south, and so on. And we're going to end up by talking about how we can integrate all this with our partner solutions, with the gateway load balancers, and so on. Great. So why we inspect traffic and what are the challenges that our customers go through? So there's always, even in AWS, we have a saying that we always need to look around the corner, right? So when we look at traffic, we have applications, we have customer data, we have a lot of these things that we need to make sure that it's secured. We need to make sure that our environment is secured, and we cover all the scenarios. The challenges is that sometimes we miss a few things, and that's why we need to look around the corners. And this is when we talk about we need to test everything before we go into production, for example, right? So how we can inspect traffic in AWS? We like I mentioned, there's a lot of scenarios that we need to cover. We need to look around the corners. And from AWS, we have bunch of services that can help you diagnose and monitor your traffic in AWS. We have AWS WAFF to protect your application at an HTTP level and application level. For logging monitoring, we have on a VPC layer, we have VPC flow logs that can look at the network flow in and out of your VPCs. We have our network firewall, which we're going to go into more details about it. And we have other services about compliances, and we have at the edge network solutions. We can inspect for DDoS attacks, for example. We have services also like Shield, we have Guard Duty, and so on. And this helps you to inspect different kind of scenarios with AWS. You have all these options to help you to do that. So what challenges do we go through? There's a lot of network topologies that the customers can go to. There's a different ways on how to do things in AWS. And we want customers to actually build and try new things and try different ways on how to implement things. You can have all your traffic in the same VPC, which can make it easier. If you have one VPC, one subnet, everything goes into that subnet, leave. So there's no problem there. You can monitor that one entry. But then the challenges comes as we scale at AWS. And people call it challenges. I like to use the term how we scale, how we monitor our network as we grow. And that's when we talk about different network topologies. We can have everything set up in one VPC with one subnet. We can have it across multiple subnets, across multiple availability zones. We can start building applications in different VPCs. We need to peer these VPCs. We need to scale how we connect all these infrastructure together, how we can make it private, what to expose to our external customers, and we might have traffic in and out coming from a local data center and so on. So there's a lot of scenarios that we need to cover. There's also talking about how we can monitor traffic at the different network layers. We need to look at it from an application layer, we need to look at it from a network layer, and so on. And from that, we need to have more control on what we actually look inside the packet. And for that, we have Amazon VPC traffic mirroring. So instead of just looking at the traffic on a subnet level, we can even go deeper into that and look into packets. So customers want to do a lot of things when we talk about traffic inspection. So talking about how we can monitor our traffic, we need to start exploring services that can allow us to monitor traffic coming in and out from my subnets on a network level, on an ANI level, and for that we have VPC flow logs. VPC flow logs is our service to collect logs from your subnet. You can do it on a subnet level, you can do it on an ANI level, which can help you to inspect the traffic that coming in and out, whether if it was accepted or denied. It's like a network flow that you can monitor in your VPC. And that can allow you to have an understanding on how the traffic flow inside your networks. That can also be integrated with third-party solutions that can allow you to do more analysis on what's happening inside your network to try to understand the traffic. And like I mentioned, you can do it on a subnet level or even on an ANI level. You can have different intervals with it. You can have an interval between 1 to 10 minutes. You can even use it with Nitro instances to look at traffic within 1 minute. So there's different options in how to do that. And how the log looks like when you create it, it's like you see in the diagram. You can have filters to look at the traffic if it was accepted or denied. What is the interval of the traffic that you want to monitor, and so on. So it provides you with a lot of capabilities to look at the network flow. How it looked like? It's very simple. This is how the flow log looked like. It will show you, for example, the account ID. This is how the file looked like in your. You can even configure it with CloudWatch to ingest all these logs into CloudWatch to have a visibility over it. And once you create it, it will create a bucket in S3, which is our object store service. And this is where we store everything there. Then you can utilize that to actually analyze the traffic that's coming in and out. Great. And with flow logs, we have different versions. With that, that you can configure it with flow logs. And the cool thing about this that each one of these have a different use case with our customers. You have version 2, which is the default that comes with flow logs that allow you to do inspection on an account level. You can see the network ID that the traffic coming in and out, the number of packets, the bytes, the start of the session, the end of the session, and so on. And then you can start building on that. In version 3, you can look at a VPC ID, a subnet ID. In a version 4 perspective, you can look at it also from a region perspective. So you have different options on how you can do it with flow logs to allow you to have more visibility and scale how you want to look at your traffic in and out. Great. So a few things to know about flow logs. That's my colleague there. Yeah? Yeah, I'm gonna take a pause until my colleague comes because he arrived. Hey. So we were just talking about VPC flow logs, and then we get to the section where we have a few things that you need to know. I think it's on. Yeah.
Am I on? Can you hear me? Thumbs up. Listen, little Betsy here has some problems. She's very stage fright. So this morning I was getting started, and she was like not really having it. So I apologize. I'm late. Bro, you covering for me? We're up. What are we talking about? Flow logs.
Flow logs, and then a few things to know about flow logs.
A few things you got to keep in mind. Did we talk about how they're not enabled by default?
No, not yet. Not yet.
Okay.
That's on you.
Well, let me get started on that. So you have this little introduction to flow logs and everything, right? That's cool. So we talk about flow logs not being enabled by default. And that's true. So at the moment, there's no policy you can enable that turns them on and makes it so that any VPC automatically gets turned on and has them enabled. So one of the things to keep in mind with flow logs for observability is you should be tracking your cloud trail and making sure that you're watching for events for VPC creation, VPC deletion. Go out and clean that up, right? Use things like Lambda and step functions to go out and enable your VPC flow logs, consolidate those VPC flow logs into a common bucket, right? We talked about the universal format. Did you talk about the version 3, version 2, version 3, version 4? How many versions are there? Somebody use their hand. Okay, right? Everybody's using the latest version, right? It's really the most information you're going to get out of your VPC flow logs is by enabling the latest version. But, you know, if you've got some old workflows, if you're using some older open source tools or something like that, those things can still want like version 2. It's time to get them to upgrade. Make sure you go out and issue that Git issue on the project and be like, hey, we need to support v5. If you get the clicker,
Yeah.
well, let's try that. Does this, woo? The field source and destination address. This is one, the second one that gets people all the time. Source and destination address. See, the thing is as your packets are moving through your AWS network in your VPC, you're jumping through things like load balancers. You're jumping through things like NAT gateways and stuff. So you're getting multiple VPC flow logs that have to be put together to be able to tell the entire story, right? So if you have something like a security event that needs to be investigated, you've got to be able to see what that looks like from start to finish, right? And the only way to do that is to make sure that you are stitching those VPC flow logs together. If anybody wants to talk about how to do that, by the way, if you want some advice, we can talk afterwards. But we have some really cool Athena scripts that can help you put all those VPC flow logs together. So flow logs don't capture all IP traffic. This one's kind of funny to talk about, right? Because we like to say, you know, use flow logs, get everything that's going on in your VPC, and it's going to be awesome. Except that there's a handful of things that don't occur, right? So keep in mind of what they are. They're all small management and maintenance stuff that's going on in your VPC for our services and stuff. So there's documentation that talks about what it is. So just be mindful of that. And so when we look at a VPC flow log, like, we can do some cool stuff, right? If we've got it centralized and we're able to tell that whole story, then we can take security findings that bubble up from things like guard duty, right? So here you've got a guard duty finding. This is EC2 port sweep. And this is actually an event that I generated on purpose using really common like script kiddie tools, right? So, and it generated guard duty. Guard duty caught it for me. And so I can go out and using something like Athena, I can go look at those VPC flow logs and I can do this query, right? What is it doing? What is that endpoint doing? So with a simple select for the destination port and protocol and the source address, and all this information is in the guard duty finding, I can actually get this list, right? It's walking ports, right? It's doing a big nmap sweep across the entire, you know, some endpoint IP address. And we can go look this up and find that there's like 500 plus entries in this like 10-minute window. So then we can start digging in and say like, well, that is seriously suspicious. What else is it doing? Are there IP addresses out there that we've been banging on because maybe we forgot to control our outbound firewall policy a little bit? It's okay. You know, should I expect this wave of like abuse emails to notify me that I'm participating in a, you know, DDoS event? So we can go out and we can look, and sure enough, you know, we can see that endpoint's been talking to a lot of stuff, right, over the last 24 hours. And so we can go continue to drill down in and see what it's doing. So AWS WAFF is another spot where we can look at what is happening with my workloads and my endpoints, right? So AWS WAFF has its own logging mechanism. And because you can terminate your SSL on WAFF, it means that, on ALB and attach WAFF to ALB, It means that you can get a clear text view of what's going on in those requests, right? So we can set up logging. We can do that and centralize it again into a security account or a logging account where we want to wrap our tools around. But it'll give us a chance to see what the requests look like. And this logging is separate from like the Elastic Load Balancer logging that ALB is going to produce or that API Gateway is going to produce. Like this is WAF's own logs. And why is that important? Well, that's because the WAF logs include the information about what is it doing to the request? How is it evaluating the request? And if a request gets blocked, why did it get blocked? What rule triggered it, right? So that gives us a chance to kind of collect all that together and start to decide, like, am I seeing a common pattern of malicious abuse against my endpoints, right? Am I seeing stuff that maybe I need to go evaluate the rule and tighten it up a little bit or loosen it up? Because the same thing happens in the other way. If you implement a law, a WAF policy, and it starts blocking your legitimate traffic, these logs are key to understanding that so that you can go back and you can loosen those logs as needed, right? So this is what the log kind of looks like, right? So this is a JSON document. This comes through. It gives us some key information, right? I've got a client IP, the IP address of where it came from. I've got a bunch of information about the policies that it hit, what was the request, what it looked like, how big it was it, information around the client. So, and that last line that's highlighted in the bluish green there, that is the rule that hit. So this block event is it was triggered by that very last rule, the bot control set. So, okay, traffic mirroring. So, what is traffic mirroring, right? So this is back in the day when we think back to our on-prem and we think about, our gruffy security guy who is dying to hold on to his packet broker, right? Like he loves his Gigamon, loves his Ixia, whatever product they want to use. Well, some of those things you can get out of that can be brought forward into AWS through traffic mirroring, right? So traffic mirroring allows you to forward the packets as they exist, as they're hitting, what they look like as they arrive to an ENI, and forward those to a listener that can then collect them, process them, evaluate them, whatever makes sense for you, right? So you basically get these core benefits, right? Is that it's pretty straightforward to set up. We're going to create a mirror. We're going to define through a filter what it is that's going to get captured, and then we can forward that to any number of partners or open source products that can process that data. So, okay, so how does traffic mirroring work? Interesting question. It works like this. So basically on our SDN, on our software-defined network underneath in our hypervisor, we're taking those packets. We're going to embed them, encapsulate them. There's the word I was looking for. Encapsulate them in a VX packet. And then that gets forwarded to a mirroring endpoint. And that mirroring endpoint can be like an ENI of a standard EC2 instance. It can be the endpoint of a network load balancer, and we'll kind of look at what that looks like. But it forwards it, and then you unpack that VXLAN, that VX frame, and you have access to the raw packet. So the thing is, the traffic mirroring source and the target, the traffic mirror target, they can be in the same VPC, but they don't need to be. You have to simply have layer 3 routable access, right? So that means that if you really wanted to, you could stretch that mirroring target across your transit gateway into a whole nother account and forward that traffic there, being mindful of those costs, right? But you could absolutely do it. So be in different VPCs, in different accounts, whatever sort of makes sense for you and your security policy, right? So this is kind of a best practice approach. So here we can see we've got some EC2 instances that we have set up for traffic mirroring. We've defined the filter for what we want. Be it like, hey, send me everything. And then what we're doing is we're sending this to a network load balancer endpoint. The NLB allows you to like forward as much data as you want at scale, and then manage it through whatever resources you want to put behind it, right? So there's a couple of different partners and stuff that can consume these and unpack them. Suricata comes out of the box ready to go, and you can essentially deploy it on an EC2 instance with an auto-scaling policy. And as you forward more traffic to this NLB endpoint for inspection, it will launch more and more Suricata instances. And then it requires some orchestration so that you can get your data and analysis aligned. But basically, you'll be able to deploy that and absorb that mirroring traffic. So when we talk about filters and sessions for mirror traffic, this is what some of the ways that we can act on those, right? We can do traffic direction, inbound or outbound, what the action is, whether it was accepted or rejected, the layer 4 protocol, the source port range, destination port range, source and destination CIDR block. Or frankly, you can really just define it as like star, right? Like just send me everything. And then the packets that match that policy will be forwarded to the mirroring target. So there's a couple of things to think about. And this is, just like you would have to consider this for any type of on-prem packet broker, right? There's a sizing consideration when you're on-prem, right? And your sales people show up and are like, you need the largest packet broker we sell with as many 10 gajillion gigabit per second ports, and you go, yeah, that's exactly what I need. Like traffic mirroring is kind of the same, right? The biggest consideration is that mirrored traffic, right, counts toward the instance bandwidth. All right, so I would say let that sink in for a second. That means if you've got an instance that you've deployed that has a 1 gigabit ENI, if you are already receiving 500 megabits of traffic to that endpoint and you turn on traffic mirroring for everything, you are now saturating that endpoint throughput, right? So be mindful of where your traffic utilization is. So if you've got an ENI that's running at 80% of its capacity for that EC2 instance, then the first thing you should be thinking is, how do I make my architecture work better so I'm not sending using 80% of the throughput of my ENI? But then if you need to turn on traffic mirroring, you should also consider that you won't be able to do full traffic mirroring with that type of throughput, okay? The production traffic has a higher priority. So in places where there potentially is like congestion, mirroring traffic is going to be dropped. So we treat the traffic mirroring as essentially like our best effort, right? Which 99% of the time is going to be fine, but if a congestion ever occurs, we will drop the mirror traffic. The flow logs don't capture mirrored traffic. So remember back a couple of slides ago, we were talking about like some flow log considerations. This is one of them. So keep in mind that you won't spot that. Packets that are dropped for the traffic mirror source by security groups are not mirrored. And this is sort of a weird one, but it's because of where that security group evaluation is implemented, right? So just keep in mind that if you've got a security group that is blocking, or ACLs that are blocking for your VPC, right? You're gonna lose some visibility. We just talked about the recommended network load balancer. That way you can keep up with any level of traffic mirroring that you want, as long as you've got, the capacity behind it to meet it. Think auto scaling group, right? Let's see, and then, cross zone load balancing when your network load balancers to ensure that your packets continue. And this is just simple good practice from a multi availability zone, right? If a zone goes offline, your traffic mirroring is highly critical to your security. Then just make sure that you're doing good practice for resiliency design. So now I will pass you back over to the gentleman who started this whole thing and was taking over for me. Asha, there you go.
Thank you so much, Jeff. Awesome outfit. Thank you.
I know there's a power switch.
Yeah, I'm not sure. Anyway, so let's talk about more use cases. We spoke about how we inspect traffic, how we use flow logs for that, our different logging mechanisms. And now let's talk about different use cases and how we filter traffic on AWS. So what to consider? And I mentioned this earlier, that we always need to be able to look around the corner. I can look at my traffic in a VPC. I can have everything in a VPC, like I mentioned earlier. I can have multiple subnets within that VPC, and I have cross communication. I might be deploying different instances. They need to send traffic between each other. That we call east-west traffic. But I can also deploy my applications into different VPCs, but we're still in the same region, right? I chose my region, which is closer to my customers, my end users, and I'm deploying my applications there. I have one application VPC1, another application VPC2, and I need to connect these two VPCs because there's traffic going between these applications, they're connected. So I also need to keep in mind what is allowed between these two VPCs. I need to monitor the traffic and so on. But again, we're talking AWS about scale, how we can scale, how I can deploy globally. So I can have another application or the same application running on a VPC in a second region, on a third region, and I need to communicate all these applications globally. I might have another customer or a third party that always also using AWS, and they have their own application that needs to speak to my application, and I also need to connect them in a different region. So that's another use case and that I need to pay attention to on how to filter traffic. Another one, a lot of customers also use hybrid networks. They still have their legacy applications on-prem, or they have different applications, some running on the AWS cloud, some running on-prem. I need to connect the two privately. I can use VPN connections. I can have a direct connect. I also need to think about the traffic. How can I secure it? How can I filter traffic? What is allowed? And actually log what's happening between south and north. I also need to look at my internet traffic. There's a lot of customers sending traffic to my applications, connecting to it. I need to install patches. I need to connect to external vendors. I need then to consider my ingress traffic to the internet and egress traffic, and look at the two use cases. I need to be able to filter the traffic coming in and out from the internet. So this is where we talk about, we need to look at security now in a different layer. Right? So when we talk about inside my VPC, I need to secure my resources on a resource level. We talk about elastic network interfaces attached to my EC2 instances. And these instances are inside the network called a VPC, but we divide it into certain subnets, each one in different availability zones. So I also need to secure that on that level. So the first layer will be my instance. And for that, I have security groups, which is our stateful firewall. that I can filter traffic on that level. And then I can filter it on the network level using network access list. And each subnet has its own network access list. So I can now even filter traffic between different subnets inside the VPC. And then also give me control to what's allowed and what's not allowed in and out from my VPC. And then we talk about, in the VPC, we talk about boundaries. We have group of instances, and I also need to inspect what's going in and out and filter that traffic. We spoke about different services to inspect traffic. For that, we have flow logs and everything, and we covered that. But then I want to also inspect traffic from using firewalls. And for that, customers used to have different appliances running on their VPCs to filter traffic. And then we introduced the gateway load balancer to make it scalable on how you deploy your firewalls on AWS. And then we actually launched our own managed service, which is Network Firewall. And we're going to talk about it. We're going to talk about both of them in more details. We covered AWS WAFF, which is our application web firewall. And then from observability perspective, we spoke about how we can collect logs on a VPC. We have VPC flow logs and traffic mirroring that we covered earlier. And from orchestration perspective, we want to also be able to deploy this not just in one VPC. We want to automate things. Our customers like to automate and scale things. And for that, we can use our network firewall manager that can work well with all of our managed services to deploy it across multiple accounts, different organizations, different regions, different VPCs. So first, let's talk more about Network Firewall. And Network Firewall is actually our managed scalable solutions that customers doesn't really need to worry about the underlying hardware. Once you create the Network Firewall, it can manage itself, it can scale in and out depending on the traffic that you need to send to. With Network Firewall, you can automate and you can centralize how you can create policies and rules to filter traffic in and out from your VPCs and decide what is allowed and what is not allowed. You can actually monitor the traffic also, another mechanisms of monitoring traffic in AWS, utilizing Network Firewall, and that works very well also on how to push these logs to S3, Kinesis, CloudWatch, and how you can integrate it with third-party solutions as well from our partner network. This allows you a Network Firewall to secure the traffic even between subnets in the same VPC. So now we have the capabilities between subnets in the same VPC. We can filter traffic before we send traffic across. Network Firewall works very well also with our managed services like Direct Connect VPN and transit gateways and so on. Right? The cool thing about Network Firewall that it works well, like I mentioned, with Firewall Manager, so you can actually automate all these deployments and policies across different AWS across your AWS organizations in different accounts and different VPCs. More about the Network Firewall capabilities. It do packet filtering, and there's different things that we can do actually here with Network Firewall. You can do the normal that we used to use with security groups and network access list. You can have stateful and stateless rules. You can actually have filtering on an HTTP level for unencrypted traffic. You can actually also have IPS on your in a live way actually for your traffic on your VPC. So it provides more capabilities than the traditional ways on how we used to filter traffic besides security group and access list. Like I mentioned also, it provides you with visibility and reporting mechanisms. You can push logs into CloudWatch, integrated with third-party solutions to actually allow you to analyze the traffic that come in and out of your VPCs. And like I mentioned, the cool thing about it is a centralized management tool to configure all this in your accounts in an organization, and it works well with the firewall manager. How it works? A network firewall works in a certain way when we talk about routing. I hope all of you are familiar what is an endpoint, VPC endpoints in AWS, and we use VPC endpoints with a lot of other services. And here we also introduced one for network firewall, which in the background of it is the same as the gateway load balancer endpoint, and we're going to talk about it later on also. So what happens is you will have your workload running on a certain subnet. And let's say that subnet in this example want to send traffic to the internet. So what you do, the routing for your workload will be to your firewall endpoint when you create it in a separate subnet, let's call it the firewall subnet. That firewall endpoint, when you create it in that subnet, will be connected to our network firewall. So your protected subnet, where you have your workload, it will have an elastic IP, which is a public IP associated with it. In a normal way, you would have sent the traffic directly to the internet gateway. But here, when we use a network firewall, your gateway will be that endpoint for the firewall. So the first thing, we send the traffic to the firewall endpoint. It will send it to the network firewall from AWS to inspect the traffic to see if it's allowed or not. Send it back to the endpoint, which will have a default route to the internet gateway. So now our default routing happens on the firewall subnet. Then the endpoint will send the traffic to the internet gateway, where I will have my NATing there for my elastic IP, send it to the internet, comes back. Same way, the moment it arrives to the firewall endpoint, it will send it to the firewall to inspect the traffic before it sends it back to the source instance that initiated the traffic. Great. So now we have that extra layer in between to which is our endpoint to filter traffic. But now, let's talk about different scenarios on how we actually inspect traffic in AWS. There's two ways on how you can launch resources. There's one that we call the distributed deployment model. And here we have separated resources for each one of our VPCs. You will create one VPC, you will have your firewall there, you will have your WAF there, and that's separation. Each one will have its own rules. And just for reference, in all the slides, you can apply the same thing either with gateway load balancer and appliances from our partner network, or you can use our managed network firewall. So it's the same deployment. But when we talk about topologies with networking, you can have a distributed deployment model where you have different VPCs, and each VPC will have its own WAF, its own firewall. And when we talk about it from a WAF perspective in a distributed model, here you will have one VPC, you have your application load balancer connected to EC2 instances. That application load balancer will be configured with AWS WAF. So when the traffic comes from the internet, this packet will, when it wants to hit the application load balancer, it will be filtered with AWS WAF before it's sent to the destination EC2 instance behind the application load balancer target. So now, in each application, I will have one ALB, I will have one WAF for it to inspect traffic. I can build on that. For that one application, on top of the application load balancer, I can have our CDN solution, which is CloudFront. And for CloudFront, I can have another WAF for it. So when the traffic comes from the internet, it will hit the CloudFront, will be inspected by the WAF configured by the CDN solution that we provided. Then it will go to the application load balancer, be filtered again with the WAF configured with the ALB before it's sent to its destination instance. So this is in a distributed model. But now let's centralize things. Instead of creating resources for all of our VPCs, for some customers that's an extra cost because we're running a firewall, a WAF in each one of the VPCs. I want to centralize things. And for companies, when they want to scale, they want to have, for example, an inspection VPCs in a networking account. So all my security and networking resources will be in one account. I want to centralize everything in that account for better visibility for the networking and the security team. So in a centralized deployment model, I will have all my spoke VPCs. Each one might have one, two, multiple applications, all connected using our service, which is called Transit Gateway. Transit Gateway, it's like our virtual router that connects all these VPCs together. And I will create a separate VPC, which I will call my inspection VPC, where I will have my firewall or the gateway load balancer with my appliance running there. And what happens here, I want to inspect all the traffic coming from these VPCs through that inspection VPC. How? So, like I mentioned, you will have two applications, let's say, running in two VPCs. Like you can see here, VPC 1 have 10.0.1.0/24, and you have the other VPC with 10.0.2/24. Each one of them, like, they will be connected using Transit Gateway to be able to connect to each other. You can see that there's a separate subnet in each one of these VPCs with the Transit Gateway endpoint to connect to the Transit Gateway to be able to communicate externally. And then I created a separate third VPC, which I call Inspection VPC. And that Inspection VPC will have the gateway load balancer with the firewall behind it, or our managed AWS network firewall. The transit gateway also will be connected to that one. So now we have the three of them connected. How that works? My routing tables for the instance where my application is deployed will point everything to my transit gateway endpoint. So the traffic from VPC1 to VPC2 will go through my transit gateway endpoint. But now the magic happens on the transit gateway where I will have different association with different route tables. And I will have one route table that when the traffic comes from VPC1, all the traffic will not be sent to VPC2. It will be first sent to my inspection VPC. It will get to the inspection VPC to my gateway load balancer or to my network firewall. The traffic will be inspected, routed back to the transit gateway, then to the destination VPC. When there's a reply for the packet from VPC2, the same thing happens. It will go through the transit gateway to the inspection VPC back to VPC1. So now I centralize all my inspection and filtering on that inspection VPC. How is that useful? I'm managing one inspection VPC and I'm plugging VPCs to it. So that can help me actually scale while adding more VPCs and so on and so on. Some customers might think of that as now I need to have a transit gateway. I need to pay for traffic that process there. Still, I'm saving cost on not replicating my firewall resources. So it's also a business decision what can fit to my workload better. And we need to think on how we scale, right? The other use case that I wanted to cover is that we spoke about deploying everything in one VPC, but what happens when we talk about deploying everything across regions? So now our transit gateway is a regional resource, so it works in one VPC. So in this use case, I will have in region 1 an inspection VPC connected to a transit gateway in that region to all my VPCs there. And then I will have my second region. It will have its own inspection VPC with all the VPCs connected to each other with the transit gateway. Between the two regions, we have the capabilities to connect the two transit gateways in a peering connection across regions. So how the traffic works here? When anything behind transit gateway 1 want to speak to the second region, my gateway will be that attachment, which is my second transit gateway. And then I need to have another route table to inspect traffic in the first region. So how this traffic happens, So how the traffic happens, let's say VPC1 wants to speak to VPC2. So the traffic first goes to my transit gateway. The transit gateway will send everything first using the first route table to the gateway load balancer or my network firewall to be inspected. Then it will be sent to the transit gateway. The transit gateway will have another set of route table that then will send all the traffic to the destination transit gateway because my destination is VPC2. The traffic gets to transit gateway 2. Now it needs to be inspected again before we send it to the destination. So my route entry here will be to send it to my firewall. Then it will be inspected, sent back. Then the transit gateway will send it using another set of route table to my destination instance. The same thing happens when the instance wants to reply. It goes to transit gateway 2, sent to the inspection VPC for inspection. If it's allowed, sent back to transit gateway 2, then sent to transit gateway 1, get inspected, comes back to the transit gateway, and sent to the destination instance. So now each region has its own inspection, and then I can connect everything globally in AWS. Pretty cool. We covered it with network firewalls and gateway load balancer, but let's go back also on how we can centralize it using WAFF, which I started with. In a centralized model, using our AWS WAFF, we spoke in a distributed model, everything will be in the same VPC. But now I want to centralize everything using one application load balancer and one AWS WAFF. So I will have one VPC with my application load balancer configured there with my AWS WAFF. And then that VPC will be connected to my destination VPCs using transit gateway. Remember, application load balancer works with targets. And each target can have a set of EC2 instances that can be one application. So depending on to which application I'm sending the traffic to, I have one ALB, and the target's EC2 instances are registered in remote VPCs. So how the traffic comes in? Comes from the internet. It wants to connect to a certain application. It hits that ALB in my centralized VPC, get inspected with WAFF, and now my target is a remote EC2 instance in a remote VPC connected to me using my transit gateway. So it will be sent using the transit gateway to a network load balancer to these EC2 instances. Why are we using a network load balancer here? Because ALB cannot point to another ALB as a target. It can only have EC2 instances or elastic IPs. And because my network load balancer has an elastic IP, I can register it as a target for my application load balancer. So the traffic comes from the internet to the ALB, get inspected with WAFF, sent, my target is my network load balancer, sent through the transit gateway, hits the network load balancer, and then it will be loaded, load balanced between the instances behind it. Hope that makes sense. Another way of doing it, instead of using transit gateways and to connect the VPCs to each other, there's another way of doing it using private link. AWS private link allow you to connect to applications in remote VPCs securely without the need of a transit gateway. But here I will still need to use endpoints. So what happens is I will have also in one VPC, I will have different subnets for my application load balancer with WAF configured with it. And then I will create another set of subnets where I have my private link endpoints. These endpoints point to a network load balancer in a remote VPC. So when the traffic comes in, it goes through the application load balancer, get inspected with WAF, sent through the private link endpoint to its destination network load balancer when my application sits behind it. So that doesn't limit me that I only need to have distributed or centralized deployment model. I can actually have both combined. So in this example, you will have that transit gateway in the middle. You will have applications running on different VPCs, and then I will have one inspection VPC. And this VPC1, VPC2 will inspect traffic using that inspection VPC. But at the same time, I can have another VPC, let's call it my edge VPC, with its own firewall or gateway load balancer configured with it. So I don't need to use the inspection VPC for my traffic filtering. So I can have both now. So you can think about it for different use cases, which one needs, it has its own dedicated resources, or which VPCs needs to have a centralized inspection. You can think about it like I have customers that want to plug into my transit gateway. They already have their own inspection, so they don't need to use my inspection VPC. And then for my environment, I can have my own centralized inspection. We talked about our network firewall as a managed service. Now, I also mentioned our gateway load balancer that works well with our partner solution. So customers, sometimes they don't want to use our managed services. They want to have more control over their firewalls or have more capabilities. So they go for third-party appliances from our partner network. And for that, initially, customers used to launch these EC2 instances. They need to think about how to scale, failover. If something happened in one of the instances, how they can failover to another one. So we introduced the gateway load balancer, which is another type of load balancers that we provide from AWS that works with these appliances. So how it works, the traffic needs to hit a firewall. It will come from a source IP. It will go to a gateway load balancer endpoint, and this is what I spoke about. It's the same endpoints that we use in our VPCs. That endpoint will be connected to our gateway load balancer. So the traffic comes to the load balancer. That endpoint will be connected to different destination EC2 instances to load balance the traffic between them. So that helps me scale how I can configure my appliances. How is that helpful? That allow me to utilize these appliances, scale it, don't worry about availability for it, because the gateway load balancer will take care of that. I can utilize auto-scaling group from AWS and so on. When should I use when? There's no wrong answer or a correct answer here. If you want to use our managed service, which is the Network Firewall, don't worry about the underlying infrastructure for it and how it's scaled and so on, and you just want the firewall to inspect traffic for you with all the capabilities that comes with it, you can use the Network Firewall. The Network Firewall, like I mentioned, in the background, it actually uses the gateway load balancer endpoints. So it's kind of the same thing, but instead of pointing to a third-party appliance, we're pointing to our managed firewall. So if you want to have more control of your firewall, or there's capabilities that you want that our network firewall doesn't provide, you can go for any of the appliances available on our marketplace and use it behind our gateway load balancer here. Great. So Gateway Load Balancer works well with a lot of our partner solution. We have a lot for advanced security partners. We have Checkpoint, Trend Macro, Palo Alto, and many more. We have also partners for analytics and data filtering, like NIS304. For orchestration, we have Cisco, Terraform, and also we have partners with system integration like E+. So you can deploy any of these solutions from our marketplace and use it with our Gateway Load Balancer. Or you can just build your own solution. If you want to use anything in a Linux box, you can do that as well. And then it can still work well with our Gateway Load Balancer. So you can explore a lot of options there. Cool. And that takes us to the last slide. I hope you enjoyed the session. And please complete the survey and enjoy the rest of your day in Reinforce. Thanks.